Assalamualaikum warahmatullahi wabarakatuh. My name is Nazifah Hanis binti Muhammad Nahar. My system is Conducive Study Room Recommendation System for ODL students using 9PS algorithm. Okay, let's start with the scope of this project. This project is meant to help ODL students on improving their learning environment at home. Learning environment plays a vital role on students' ability to stay focused throughout the online classes. A conducive study room will ensure students to stay focused longer in classes. To assist students on improving the condition of unconducive study room, this project will then recommend 6 factors that contribute to a conducive study room. The 6 recommendations would be room layout, wall color, temperature, direction, height of chair, and height of table. Alright, so let's start with background of study. The study is based on open and distance learning students, where based on survey done by Barnes and Noble College Insight, 64% of survey respondents expressed concern about not being able to focus in class. Next is on improving students' learning environment, where quality of the physical environment significantly affects student achievement as it heavily determines a student's emotional being. Moving on to problem statement, the first problem is difficulties of ODL students in staying focused throughout every online classes. The second problem statement would be unconducive learning environment which affect the ability of students to focus in class. The third problem statement is unsuitability of conventional method and existing app on solving ODL students' lack of focus. The example of conventional method would be drinking water and taking 5-minute breaks, and these are the example of existing app. For objective and scope of the project, the first objective is to design a conducive study room recommendation system based on ODL students' geographic and demographic data. The second objective is to develop the design system using 9PS algorithm. Lastly is to test the functionality and usability of the system. Here is the methodology of the project. So 9PS algorithm is used to develop the system. Flash Python framework is used to run the architecture of 9PS algorithm. Jupyter Notebook is used to evaluate and train the classification and recommendation model. System is conducted on a laptop. Before we proceed with the system demonstration, I will first explain the workflow of the system to give a clearer understanding of the system. The system consists of 2 features. The first one is for user. In user feature, there will be room categorization and also recommendations to improve the condition of study room. As for admin feature, there will be data visualization and also model accuracy. For the system demonstration, I will start with the user's features first. This is the homepage of the system. User will first need to use the room categorization function to know whether the study room is conducive or unconducive. By clicking on the Get Started button, user will be directed to the prediction page. User need to input their data according to the question asked in order for the system to classify the study room. Okay, so let's input the data. Click on Predict button. The result will be displayed on the result page. In this case, the classification result is unconducive. Your room is unconducive? Do not fret. To improve your study room conduciveness, the system can recommend 6 improvements, which are room layout, wall color, room temperature, direction to study, height of table, and height of chair. Let's say user choose to change their wall color. Again, user needs to input their data in order for the system to make recommendation. Ta-da! The system recommend the color while user can download the result for reference. Let's try another recommendation, temperature. So input the data and predict. The system recommend to set room temperature to less than 21 degrees Celsius. User can verify the recommendations by trying the room classification again. So input data with the recommendation made by the system. Voila! Room is now conducive. The second part of the system is the admin feature. Admin will need to input the correct username and password to log into the admin system. This is the admin homepage. Admin can view the data visualization of the datasets used to train the system. Admin can also view every model accuracy to get a better understanding of the system performances. Now, we will discuss on the result and discussion. Shown here is the room classification model accuracy. As you can see, the accuracy percentage for conducive classification is 67.23% and the accuracy percentage for not conducive classification is 63.64%. Both of these contribute to the overall accuracy of 65.60%. It can be said that the room classification model is reliable as the accuracy achieved is high. Now, we will discuss on the recommendation model accuracy. So here is the accuracy for the 6 recommendation model. So as you can see, the accuracy for room layout is 45.64%, followed by wall color, temperature, direction, table height, and the highest accuracy is for chair height. In conclusion, Conducive Study Room Recommendation System is a combination of one main classification model and 6 supporting recommendation models with additional functionality built in as a whole system. For the classification model, it allows users, especially ODL students and parents of ODL students, to classify their study room as conducive or unconducive, as the system aims to help improving the learning environment of ODL students onto achieving a conducive learning environment. By using the supporting recommendation models, users can choose what they want to improve according to their capability, starting from simple adjustments like adjusting the height of chair and table onto a more complicated adjustments like changing the study room layout and changing the study room wall color. Users then can check on their room status by retrying the new room classification using the recommended result until they get a room classified as conducive. For future works of the system, we can try to improve system performance by training the model with greater number of data. Second, we can try to develop the classification model using other AI techniques such as neural network and decision tree and more. By exploring these AI techniques, the outcome of every technique can be compared and the best technique's performance can be known. Lastly, we can try to apply the system to other domains of similar characteristics, for example, on work from home workers, office workers, or in a physical classroom setting, so that the system becomes multi-purpose and more useful.